Hello friends, welcome to our channel Maths with Sai Priya. Today in this video we are going to solve few problems, that is a set of vectors are given over the field of real numbers and we need to check whether this set of vectors are linearly dependent or independent. So here the field is field of real numbers and the vector space is V3 which has three coordinates x-axis, y-axis and z-axis. In the first problem we have two vectors alpha 1 and alpha 2. Let us solve this set of vectors and check whether this set of vectors is linearly dependent or independent. So let us solve the first problem. They have given two vectors. Let us consider those vectors as alpha 1 bar as 2 comma 1 comma 2 and alpha 2 bar as 8, 4 and 8. To check whether these vectors are linearly dependent or independent, we have to consider a linear combination. For that we should have two vectors, two scalars a1 comma a2 which belongs to the field of real numbers, and the linear combination we can write as a1 alpha 1 bar plus a2 alpha 2 bar, that is equals to 0 vector, where a1 comma a2 are scalars, belongs to the field of real numbers, and alpha 1 comma alpha 2 bar are vectors. Let us substitute these vectors in place of alpha 1 bar and alpha 2 bar in the linear combination. Alpha 1 into, what is alpha 1 bar? 2 comma 1 comma 2 plus a2 into alpha 2 bar is 8, 4, 8, that is equals to 0 bar. Let us write in a coordinate form, that is 2 into a1 2a1 plus 8 into a2 8a2 first coordinate, and coming to second coordinate 1 into a1 is a1 plus 4 into a2 is 4a2. Coming to third coordinate 2 into a1 is 2a1 plus 8 into a2 is 8a2, that is equals to 0 vector can be written as 0 comma 0 comma 0 because we have three coordinates in the vector space. Let us equate the corresponding coordinates. We get 2a1 plus 8a2 is 0, a1 plus 4a2 is 0, 2a1 plus 8a2 is 0. These two equations are similar, so let us solve this equation and get the scalar values. We can write a1 plus 4a2 equals to 0 as a1 is equals to minus 4a2, a1 by minus a1 by 4 is equals to a2 by minus 1, that is a1 is equals to 4, a2 is minus 1. Here we got the values of the scalars, which is a1 is 4 and a2 is minus 1. Both of the scalars, a1 is not equals to 0, a2 is also not equals to 0. Here over the linear combination of set of vectors we got the scalar values, both the scalar values as non-zeros. So then the set of vectors is set of vectors alpha 1 comma alpha 2 is said to be linearly dependent. If we get values of the scalars as non-zeros, then the set of vectors are said to be linearly dependent. If the set of any of the scalar values are zeros, then the set of vectors are said to be linearly independent. Is it clear? So let's move to the next problem. Here we have, when we have a click view of two problems. Here we have two coordinates. Here we have two vectors. Here we have three vectors. So solving three vectors in this approach may take lots of time to get the values of the vectors. So let us solve this set of vectors in a different manner, which is determinant. By taking determinant we can solve. So we have alpha 1 bar as 1 2 0, alpha 2 bar as 0 3 1, alpha 3 bar as -1 0 and 1. Let us write the linear combination of these vectors. For that we do need three scalars. a1 a2 a3 belongs to R. That implies the linear combination is a1 alpha 1 bar, a2 alpha 2 bar plus a3 alpha 3 bar. If we continue doing the substituting these alphas in the linear combination and solving the vectors by equating the coordinates, then it takes lots of time. So let us solve in the determinant form. For that we can consider the determinant alpha 1 over the first row, that is 1 2 0, alpha 2 over the second row 0 3 1, alpha 3 as a third row -1 0 1. So let us solve this. Plus minus plus 1 into 3 ones are 3 minus 0 minus 2 into 0 minus into minus plus 1 plus 0, anything it can be, which is 0. So 3 ones are 3 minus 2, that is equals to 1. That is the determinant of the vectors is not equals to 0. So the set of vectors are said to be linearly independent. If the determinant of the vectors equals to 0, then the set of vectors are said to be linearly dependent. If the determinant of the vectors not equals to 0, then the set of vectors are said to be linearly independent. Hope it's clear for you. If you have any queries, you can just comment me. If you do understand the problems, please do like and share to your friends. Thank you.